Hello everybody. Welcome to the next video on vectors. In this video we look at higher dimensional vectors, beginning with two-dimensional vectors. That's all a fancy way of saying that we're going to start looking at tables. So if you think about what a table is, you can think of it as a list of lists. You have your first list, which is the first row of the table. You then have your second list, which is your second row, etc. So a table is essentially a stacking of lists. It's a bunch of lists that have been stacked on top of each other. The way that the computer thinks about that, it thinks about it still as a vector, but as a two-dimensional vector. So it thinks of it as a vector of vectors. So in this video, we are going to study, or begin our study anyway, of tables, also known as matrices, also known as two-dimensional vectors, also known as lists of lists, however you want to phrase it. So here's a table, right? This is a pretty small table. So just to be explicit about what I mean by list of lists, 152, that's a list. That's a vector, a one-dimensional vector if you like. It's the same kind of vector we have been studying, but now we don't just have that. Underneath that, we have another list. So here we have a table which we can think of as consisting of two one-dimensional lists. So how do you create a table inside of memory? How do you create a vector of vectors? Well, the syntax is kind of suggestive here. This is saying vector of vectors. And then you have to give it the data type, like always. So if you were going to create a table of integers, you would have to put int right there. But you can also have a table of characters or a table of strings, whatever. You have to give it a name, and then here's where you tell it the size of the table. So you say m for the number of rows and n for the number of columns. This is how you create or how you declare a table inside of memory. So just for example here, here's how you would create a 2x3 table of integers. A table with 2 rows and 3 columns. Okay, so this syntax is kind of obnoxious, I should say. So I apologize for how sort of counterintuitive this declaration structure is. Clearly, if I were building C++, or if you were building C++, the declaration syntax would look something like this. Vector, tell it the name or the kind of data you're going to put in, give the table a name, and then just tell it the number of rows and the number of columns like this, and be done with it. So this right here, to me, is a much more intuitive way of creating these things. But unfortunately, C++ will not recognize this, okay? C++ recognizes this. So this syntax is obnoxious enough that you don't need to memorize it. I would give this to you on an exam if you needed it. And I'm not sure why C++ declares them that way. It seems counterintuitive to me. Other programming languages like, say, Java or something, I don't know, uses this kind of syntax. C++ uses this syntax for other kinds of tables, for array tables that we're not covering. Okay, so once you do this declaration, what happens is, in memory, you now have an m by n table of boxes, a grid of boxes, and each box is empty because you haven't put in anything yet. To access an individual box inside of the vector, you use square bracket notation just like we've done before, but now you can't just say bracket 1, because what would that mean? If you just say, hey, position 1, well, this is a two-dimensional table, so you can't just describe the locations with a single number. So if you think about the vectors you guys are used to, what we've been dealing with already, if you want to talk about position 0, position 1, position 2, etc., those positions make sense because it's just a one-dimensional list, right? There just is a position 0, position 1, etc. But inside of a table, you have to give a row number and a column number to describe the entry you're talking about. In other words, if you want to locate something, you need 2 pieces of data because this thing's a table. It's two-dimensional. So anyway, the syntax is similar to what we've done before, except now you have to give two pieces of data to talk about where you are. You have to give a row number and a column number. Speaking of that, C++, like always, starts counting at 0. So the first entry in a table, this upper left entry, that is not in row 1, column 1. That is in row 0, column 0. Okay, obnoxiously enough. So just like with normal vectors, you have to start your position counting at 0. So here, this 58 number, that's actually in the 6th row and the 8th column, but that's not how we count it. According to C++, it's in row 5 and column 7. So this equation down here is true. What is at position 5, 7? What entry is there? Well, the number 58 is what's there. That's what's at the entry in the table at this position. Okay, now let's actually go to the compiler and create a table. So here's the table from the first slide. Here's how you would create it if you wanted to just hard code everything. So you create your vector of vectors, specify integer, give it a name, and then 2 rows, 3 columns, and then you can just go through one by one and tell the computer what each entry is. So at position 0, 0, I want a 1. At position 0, 1, I want a 5, etc. So I've already typed that here. Here's what the code looks like. So there's everything from the slide. And then just to make sure that it works, I have a cout command here. So at position 1, 0. So that's row 1, column 0. That's that 3. So what should get printed here is 3. Okay, and that is what's printed. So anyway, here's how you create a table if you want to just enter all the entries by hand. Before moving on, I should mention that this apparently is unique to Eclipse. I've never seen this before, but suppose I do like that. Sometimes it won't run. Let's see if it does this time. Yeah, it says errors exist. And the reason is that it actually needs a space right here. And I don't understand why. But if you have these brackets right next to each other, it won't work. So with that space in there, suddenly it works again. So I don't know why that's the case. It's just kind of one more obnoxious thing. So in general, you don't really want to be creating your tables by hand, like every single entry being typed like this, because in general, your tables are large. So this table right here has 100 entries in it, right? So you wouldn't want to sit there, and you could do it if you wanted to. You could be like, okay, I have 10 rows and 10 columns, and what's the first entry? Oh yeah, the number 1, and then 0, 1, that's 2. 0, 3, that's 3, right, etc. You could do that if you wanted to. You'd have to type 100 lines of code. But that's not particularly it's just not something you want to do, right? So anytime you have a table and there's a pattern to the entries, as there clearly are right here, you can use for loops to create this table for you. In this case, you would want to nest them. So first, you have to figure out what the pattern of these numbers are in terms of the row and column number. And I've given you the punchline here, just in the interest of time. Otherwise, you'd have to think about this. If you're in a given spot, like say right here, this 23, how could you think about generating that number 23 in terms of the row number and the column number? Well, you're in row 2, and inside of this row, notice all these numbers are in the 20s. So it seems like the most reasonable thing to do is take this 2 and multiply it by 10, and that's what's written here. So I here is keeping track of row number, and J is keeping track of column number. So if I has value 2, then we should do 2 times 10, and then it looks like we should add the column number plus 1. So here you have a 21, but the column number is 0, so do 0 plus 1. Here you have a 22, the column number is 1, so add 1 plus 1, and so on. Here, column 2, but you end in a 3, so do 2 plus 1 would give you that 3. Okay, so that's how you can create this vector here. So let me just go to the code and create that. So clear all this out. Okay, so for row numbers starting at 0 and row numbers going up to 10, one row at a time. For column number starting at 0, column number also less than 10, column number also one column at a time. What should we do? We should take the entry at ij, we should take 10 times the row number plus the column number plus 1. And there you go. So now down here, let's ask, hey, what's at position 5, 7? And we already know, it's still highlighted there, the number 58. So this should print 58. And it does. Okay, so why is there a 58 there? Well, because when we created this, if I is 5 and j is 7, what do we have? We have 10 times 5 right there, plus a 7 is 57, plus an additional 1 is 58. So this should look somewhat familiar to you from previously. So when we first were introduced to for loops, we didn't have this notion of table in memory yet. But you guys did a couple of exercises where you printed tables to the screen rather than creating them in memory. And this has the same flavor as that. Okay, so here's how you can create a table with a pattern. So notice these two for loops are much shorter than just actually hard coding all 100 entries here. So let's finish by talking about how you print a table to the screen. To print a one-dimensional vector, there was just the same for loop that always ran, right? Start at 0, go up to the size -1, one at a time, and then print the entry there, right? So with two-dimensional vectors, there's also just a canonical way of printing them, and let me just show it to you. If you have m rows and n columns, well, you want to go row by row, and inside of each row, go column by column, and then just print what's there. Okay, so what's happening here, and again, it's similar to those homework exercises you guys had with for loops with tables already. But what's happening here is we specify an I value, like say I of 0. So once we have an I value, we go into the loop, and the inner loop consists of its own loop, where j values run from 0 up to the number of columns -1. So if I is 0, then j starts at 0, so we'd have a 0, 0 right here when we're printing. Then I stays the same, but j goes up to 1, so we do 0, 1. Then I stays the same, j goes up to 2, so 0, 2, etc. And we keep going until we're out of columns. That's what this condition is saying. Once this inner for loop is done, we then print a new line, so we move on to the next row. Then we reach this brace, we jump back up to the beginning, and the value of I goes up by 1, and we do the same thing. So let me come here, and rather than printing an individual entry, let me put that nested for loop structure here. So in this case, m and n are both 10. Oops. And j equals 0, j less than 10, j plus plus. And then I'll print the entry at ij. Maybe a space in between. Okay. And then once that inner loop is done, I'll print a new line, so I move on to the next row. Let's see what that looks like. Well, there you go, right? There is that table. The formatting is a little off here, so in the next video I'll show you how to print these nicely rather than having them not line up like this. So anyway, so this for loop structure here, this nested for loop structure, you can always print a table using that structure. Just like with one-dimensional vectors, if you write something like this in your code, like print my table please, the computer has no idea what that means. So cout can't apply to the entire table. You can only print individual entries of a table. So like it's really mad right here, right? It was really confused by that. So down here what you're saying is, hey, print to the screen the integer at location ij. Okay, the computer understands that just fine. But if you ask it to print a vector of any kind, it doesn't know what you mean. You have to print the vectors entry by entry using cout. Okay, so at the conclusion of this video, you should be somewhat comfortable with two-dimensional vectors. You should at least know how to create them and be able to make tables that look something like this. So there's some sort of observable pattern here, and you can use for loops to create this table by identifying the pattern. Okay, so that's it for this video.